Yeah, hi, Jeffrey.
Yeah, so my group, we basically have a like 4 teams working on different topic related to PFAS challenge, and we have a professor team, we have a future senator team, and future lawyers team, and future chemist team. So students were grouped into 4 teams and assumed the future role of leader in their professions. Because PFAS has been a social challenge for not only America, but many countries in the world. And it does take a village to address this social challenge. So I basically, presented a different topic for students to, develop their interest and face up the challenge, and hopefully to sort out solutions. I told my students, as a future leader, they need to do their work, not expect a lift from the coach or parents. And I presented the challenge topic for them. They got the list of references provided to them. Then they work on the topic, the exercises. And in the end, we picked the lawyers team to present, but it doesn't really represent the whole effort for the whole team, the 4 teams, to address this social challenge collectively. And just simply join the team does not make a leader. A leader is not born. A leader is made through hard work. And just like Vince Lombardi said, okay? So I'm so proud of our students here, and Claire, Emma, Tony, Ingrid, and you guys demonstrate you guys are the leaders. And I cannot tell how much proud I am. I'm ready for you to present, and also to our judges. Those students were doing their project using their little mind, bright mind, to look at the problem, go through the problems, and figure out a way through their own bright mind. I did not give them any help. And that's basically what I told them. I'm not going to give them any help. And you are the leaders, figure out a way to address the problem. I think they did a great job, and they not without struggle. And I'm hoping that the judges are realize that this are not a super academic, super technical, but is the idea to face a problem, to address a problem, to figure out a solution that count the most. And I did also invited a lawyer from actual law firm from Alice downtown, and also a postdoctor fellow from Caltech, giving them their own lectures about the corresponding topic for professors and for the lawyers. So Claire, please, without further ado, and you got 10 minutes. It took some minutes of yours. Thank you.
Okay. Hi everyone, I'm Claire, and I'm here to share our final presentation as a lawyer. Do I have Emma and Tony here to introduce themselves real quick?
Hi, I'm Tony, and I'm a part of the professor group. So basically, what is PFAS? PFAS is an umbrella term for over 4,000 chemicals, and they were introduced to the US in the 1940s. They are very persistent in the environment and in tissues because they're basically indestructible, and they can withstand high temperatures. This means that PFAS, once they're in the environment, they can bioaccumulate and biomagnify through food chains all the way to humans and cause adverse effects in living organisms. Because they are nearly indestructible, they were nicknamed the forever chemicals. And right now they're seeping into groundwater and contaminating clean drinking water, which is negatively affecting human health. Yet there are no strict regulations in California yet. Wastewater treatment plants in California also don't specifically treat water to remove PFAS because there's no strict regulation. And on the right, you could see that PFAS can be found in many products such as nonstick cookware, shampoo, paints, and just to mention a few. Okay, you could go to the next slide. And PFAS is a man-made product. You can see that they are produced in factories and can get discharged through wastewater into water, which can seep into groundwater. It can also get discharged through air. And that eventually can reach us, which were basically, we also use PFAS treated materials, and that can also basically poison us. So PFAS, the forever chemicals, are seeping into groundwater and contaminating the drinking water. And plants and animals who rely on this water are going to be poisoned as well. And this can move through food chains. And they're being released into water and air and deeply affecting our health. But with no strict regulation, there is so basically, as a professor, I would like to have a way of basically finding an MCL or maximum contaminant level to make sure that there is not too much PFAS in water wells. And you could go to the next slide. So my job was to write a grant proposal to NSF, National Science Foundation. So we included things like $1 million to buy equipment and collect data from water wells all around California, and to determine a proper MCL to make sure that there's not too much PFAS. And we could also use more communication about PFAS, so we can establish a system to notify the PFAS level in drinking water. And then also travel around to notify people about PFAS contaminating our water to show that this is a problem everybody should be aware of.
Okay, let me give you guys some background information of our case first. So the manufacturer 3MM, which applies PFAS to their products, dumps the contaminated waste into the natural environment. PFAS is a part of the same family as PFOA, PFOS, jinx, man-made chemicals known to have detrimental health effects such as increased cholesterol levels, changes in liver enzymes, increased risk of high blood pressure, and also increased risk of cancer, decreased infant weight, decreased vaccine response in children. So what if 150 local water purveyors supply contaminated water? Let's view this question as a lawyer with me. First, as Tony mentioned before, the impact on the environment. PFAS can enter the environment through production or waste streams and are very persistent in the environment, affects the soil, wildlife, livestock, and crops. Eventually, these chemicals will travel into human body. Exhaust streams, which contains PFAS, run into the ocean. It will place marine life in danger as well. So, objective view, the case is definitely going to cost a lot of not only money, but also time and manpower. However, the outcome is surely positive to human society and the environment in long term. If we get it going, the rate of cancer in human would decrease, livestock and crops would bring better harvest, and human well-being and economy will become better off. In short run, some industries with PFAS disposal will face difficulties. And this is my cost claim as a lawyer position. Okay. According to a water usage report, around 4.5 million gallons of water are used by a single well annually. In this case, 150 local water providers supply 675 million gallons of water to around 60 houses per year. If we have to shut down these water wells for 10 years to treat PFAS, there would be a revenue loss of $10 million in total. Furthermore, the case budget will raise to $50 million, including compensations for lawyers, chemists, and other necessary expenditures. All right, Tony, would you draw the conclusion for us?
So our projects will not, if it were to come true, it would not only make water safer for Americans, but also inspire other scientists around the world to do the same. With countries like US and Japan starting to realize this problem and banning PFOA and PFOS, many Asian countries like China and India are still don't have any strict regulations on these chemicals. And these are getting more and more popular and getting more manufactured. So this is only the start of getting rid of PFAS, as these ideas can travel around the globe to fix these problems to make drinking water cleaner and safer for everyone.
All right. That's our final presentation. Thank you, everyone.
Excellent job.
Thank you. Thank you.